Hello, I wanted to show you how to do number 6. It says Kim holds a 2 kilogram air rifle loosely, keyword being loosely, meaning she doesn't really hold on to it, and fires a bullet of mass 1 gram. The muzzle velocity of the bullet is 150 meters per second. What's the recoil speed of the gun? And it says here the system is the gun and the bullet. So we're just going to ignore Kim. After all, she's holding the air rifle loosely. And I drew some boxes to represent this. The big box would be the rifle, and the small box would be the bullet. And then this is before the collision. And then after the collision, we have the rifle moving to the left, the bullet moving to the right. Okay? And before the collision, we have the rifle, the mass of the rifle plus the mass of the bullet together, adding up because it's all one object. But since the velocity is 0, therefore the momentum is 0. Okay? So the momentum is 0 before the collision. After the collision, we have the rifle's momentum this way. All right, momentum, rifle. And then the momentum of the bullet has to add to that. So I'm going to make an arrow that adds to it. So momentum, bullet. The momentum of the bullet and the momentum of the rifle have to add to 0. So when placed head to tail, those vectors are just placed head to tail. There's no beginning, there's no end. You don't get a vector when you add these vectors. You get 0. Okay? And these vectors have to add to 0 because the total momentum before the collision is 0. So because the total momentum, P total, before has to equal P total after. Thus, since the total momentum before is 0, the total momentum after is 0. And the total momentum after actually consists of momentum of the rifle plus momentum of bullet. So these vectors must add to 0, which is what we have there. So let's figure out more now. The momentum of the rifle to the left is going to be the mass of the rifle times the velocity of the rifle. And that is the one we're looking for. We're looking for how fast this rifle is moving when it flies back. Okay? But we know, let's see, we know the mass of the bullet, and we know the muzzle velocity of the bullet, or the velocity of the bullet when it leaves the rifle. So the mass of the rifle times the velocity of the rifle has to equal mass of the bullet times the velocity of the bullet. Okay? And let's just put our numbers in and find, let's see, we're looking for the velocity of the rifle. So velocity of the rifle is going to be mass of the bullet, velocity of the bullet, times mass of the rifle. Okay? So when I put the numbers in, the only kind of annoying thing about this problem is we have to convert grams to kilograms. And hopefully you know that there's 1,000, whoops, there's 1,000 grams in 1 kilogram. So that means 1 gram is 0.001, 2, 3, yeah, kilograms. So 0.001 kilograms times our muzzle speed, 150 meters per second, divided by our 2 kilograms. And this should give us a recoil speed for the rifle. And let's see what we get. We got 0.001 times 150 equals, divide by 2 equals, yeah, 0.075. Okay? So 0.0, 0.0, that was fun. Get rid of that. 0.075 meters per second. And that's called recoil speed of rifle. Hope you enjoyed that, and have a good day.